Guys and girls, it's Know It time!
Alright, so today I'm going to teach you the next topic, which is permutations. So guys and gals, it's Know It time. Your favorite time of the day. Except for those who failed my quiz today. Doot, doot. And your traditional drawing, since we have some time. I'm just going to kill some time. Doot. Keep it life simple.
Yeah, like that. What's the date today?
And this is what you had last time. Here is how I'm going to work with permutations. Permutations really is something called order matters. This is key. A lot of students will have trouble with permutations. Order matters. Okay. I'm going to give you an example where order matters. Example. Your word is... what funky word can I use? Too boring. Grumpy.
Wow.
Your word is grumpy. If I ask you, how many ways can you rearrange the letter? Can you rearrange the letter? Or how many different words can you create? All the same meaning. The letters. So you arrange the letters. Guys, gals, get cracking. 720. Are you actually done? See, a lot of you, like I said, look at this and say, well, this is called order words, lettering. So you did the little blank method. 1, 2, 3, 4, 5, 6. And you just filled this in. And you said 6, 5, 4, 3, 2, 1. And a lot of you now, you can write this using factorials. 6 factorial. Go ahead, punch in your calculator. If you forgot how to do this on your calculator, you're going to need a TI-83 today. So you go with 6, hit math, and go to PRB, all the way down to number 4, hit enter. So you have 720 ways of doing this. I can rearrange all the letters 720 different ways. But now, I'm going to teach you about permutation. Permutation is when order matters. Okay? Exactly what you did before, except instead of using the blank method, there's actually a formula. The formula for this is this. Instead of using the blank method, let's write this down. Of using the blank method. I call it the blank method. No, there's no such thing as the blank method. It's my nickname. There is a formula. Is a formula. The formula is this. It's going to be P. It's called my permutations formula. N.
I think there's no formulas in this.
You don't need the formula, but you can use it if you want. Okay? A lot of people, sometimes you need it, sometimes you don't. NPR equals to N factorial over N minus R factorial. This is called your permutation formula. N stands for total number of choices. That's what N stands for.
What is N minus 1 or N minus R?
N minus R, sorry. R equals to how many you want. How many you want. Okay. I'm going to show you how to use this formula. So right off the bat, if I look at the word grumpy, I have, count how many choices you have altogether. 6. So write down N equals to 6. Out of those 6 letters I just give you, I asked you to rearrange all the letters. So we are going to use every single letter. So we're going to have R equals to 6 also. So we're going to write this as 6p6. Take a minute, fill in the formula for me, please. 6p6. I'm going to pause it, let you... So you have 6p6. If I sub in my formula, I get 6 factorial over 0 factorial. And 0 factorial really is 1. So it'd be 6 factorial over 1. So which is 6. See? That was easy. What if I ask you to do this? Only choose 3-letter words. Oh, well, sorry. 6 factorial.
Oh, yeah,
Okay, I forgot one. Only choose 3-letter words now. Your word is grumpy. How many 3-letter words can I create using word grumpy? I'm going to ask you to do 2 methods. A, you're going to do the blank method. Okay? Because you're going to have to, sometimes you got to go back and forth between the 2 methods. The formula method will not always work. The blank method will not always work. You got to learn how to switch back and forth. B, use the NPR formula. Guys, gals, have fun. See, in this question, I'm only looking for 3-letter words, not 6 anymore. So we have 3 blanks. 1, 2, 3. Robert, what goes in each one of them? Sorry? No, okay, so we have 3 blanks. How many choices do you have for the first blank? 6. Okay. Then there's going to be 5, and then there's going to be 4. If you did this right, you should have 120. Guys and gals, try using the NPR method. Okay. If you use the NPR method, we're going to have 6p. Monica, what's R? 3. It is 6p3. The reason is R is how many you want. Well, in this case, I'm only going to choose 3 letters. So which is 6 factorial, and this is why I've taught you how to work with factorials yesterday, over 3 factorial. And you can reduce this into exact same thing. You have 120. Now, if you have a TI-83 calculator, there's a shortcut on how to use NPR on your calculator. Grab your TI-83 right now, please. I'm going to show you how to punch in 6p3 in your calculator without going through the heavy calculation. So we have 6. Hit in 6 right now. So if you have a TI-83, you're going to let me show you how to save some time. Every calculator is different. Hit math for me. Go to PRBRB again. There, look, there's number 2. It says NPR. Hit enter. Finally hit 3. Okay, that means 6 NPR 3. You should have 120. So if a question is extremely complex, for example, says... Sorry?
Would you actually use the formula or can you use the blank method?
There is, when you deal with probability and combinatorics, there is no concrete method. Every question is different. This is why I said you got to get used to different types of questions. I want you to practice your calculator. What if I have 17p10? Just use a calculator, practice it. Punch in 17p10 right now. Okay. I go 17. Instead of using that formula and wasting my time, I'm going to use my little calculator. PRB, I hit enter. And I hit 10. Times 10 to the power of 10. Don't forget e to 10. So guys, hi. So this is how we work with our calculator. Instead of using the formula, we just go NPR. Try this one. Your word is Logitech. Your question is, how many 5-letter words can be created? Letter words can be created. Good luck. Any method you like this time. I'm not going to force you to do a method. You're going to choose your own method. You can use the shortcut. Using the calculator, you can use the blank. Gary, what's your work going to be? Which method do you use, Gary? NPR. If you use NPR, what's N, Gary? 8. What's R? 5. Punch in your calculator 8p5 right now. So 6,000. What's 6,720? So there are 6,720 ways. You can do this question in less than 30 seconds. Okay. This is called the power of NPR. Now here's the next question. It says, when do you use permutations? Here's a question that I always get asked a lot. When do you use permutations? Because after lunch I'm going to teach you something that's total opposites called combinations. It's a total set of new formulas. And here are the types of questions. These are general guidelines. I repeat, star. General guidelines only. General guidelines. You only use permutation when you see these sort of questions. I repeat, this is a general guideline. It's not 100% proof. It is going to be word problems. Okay? Words. Just like, example, Logitech. How many ways can I rearrange that? When you see these sort of questions, it's going to be permutation, or you can use blank method. 2, bookshelf questions. Bookshelf. Okay. If I ask you to rearrange the books on a bookshelf, it matters which way the books go. Job questions. These are the 3 most important types there is. I'm going to give you a question. 30 students apply for 3 jobs. President, VP, and what should I say is last one? Social worker. 30 students apply for 3 jobs. Your question is, how many ways can I choose? How many ways can this happen? Good luck. Yep. Yep. 30 students apply for 3 jobs. You have to have 1 student in every position. How many different scenarios can you have? Again, you can use 2 types. There's 2 methods of doing this. Any method you like. Good luck. Here we go. Who haven't asked yet? Randy, what method did you use? NPR? If you use NPR, what would you get? 24,360? This method works because it's a job question. See, order matters. For example, I could be president, I can VP. The order changes every time, so order matters in this case. Now, if you want to use the blank method, try it and fill this in. So it works. If you use the blank method, well, there's 30 choices for the first job, 29 choices for a second job, and 28 choices for the third job. See, no matter what method you use, it's the exact same thing. I'm going to give you a break, and you're going to work on this. And oh no, I can't give you a break yet. I got one more thing to teach you. Repetitions. Repetitions. This is crucial. I'm going to change the word now. Let's say if I give you the word assist. If I were to use every single letter, how many different words can be created? How many different words Notice I use the word different words can be created. Now, a lot of you say, hey, that's easy, mister. That's just 2, 4, 6. That's just 7 factorial. But if I notice, look, I'm using a lot of S's. Look at all these repetitions. So if you're using a lot of S's, your words are going to repeat. The question is, how many different words? See, this is called repetition. Here's how you work with repetition. To solve repetition questions. Oh, no, you're close. To solve repetition questions. Nope, not times. Divide. Not 3. I'm going to show you what it is. Close. To solve repetition questions, solve the question normally. Question normally. Okay, you're going to solve it normally. Exactly what you did before. There's no difference. The only thing that is different is the division step. You got to divide this because if they're the same letters, we know it's going to be less. Is the division. I'm going to show you how this works. Okay. So here's how you work with repetitions. You're going to have total choice on top. Exactly what you did before. But now, you're going to divide your answer by something called A factorial, B factorial, C factorial, dot, dot, dot. A, B, C, dot, dot, are the letters that repeat. Okay? Are the number of repetitions, basically. This will become more clear to you in a second. For example, 7 factorial. Guys, gals, look how many letters repeat. 4. Well, really, there's S, but there's 4 S's. 1, 2, 3, 4. So we write down 7 factorial over 4 factorial. Okay. And go ahead and solve this right now. 7 factorial divided by 4 factorial. Which is 118? 210? Oh, you got to solve it. 210. See, I noticed I did this using the blank method. I can also do this using the NPR method. I can write down 7p7 over 4 factorial. They're all the exact same thing, depending which method you prefer. Try this one. Your word... Whoa. Question? What's going on? Is going to be... R... The number of repetitions. The number. Your word is MICKEYMOUSE. Great show. Actually, when I was a kid your age, I used to watch a show very similar to Mickey Mouse. It's called Mighty Mouse. I don't know if you've seen it before. Seriously. No. It's a Disney. It's not a Disney. I'll show you the theme to it. It's really cool. I used to run every Saturday morning. So, Mickey Mouse. The question is this. How many...
Can you roll it down a little bit?
Hi. There is. Hello Kitty was born in Japan.
It was what?
It was Hello Kitty was born in Japan. Not in India. Whoa. Don't crush a lot of little kids' dreams. How many different 5-letter words can you create? Okay. Good luck. How many different 5-letter words can you create? Again, notice one thing. There's repetition involved. Figure out what you're going to do. I'm going to pause it, let you have some fun with it. Who didn't ask? Da-da-da. Camille, what goes on top, Camille? What goes on top? Okay. So it'll be, how many letters are there altogether? There's 2, 4, 6, 8, 10, 11. So it'll be 11. Oh no. P. Because I'm not using all the letters this time. I'm only using 5. So it'll be 11, P5 goes on top. Or if you use the blank method, it'll be 11 factorial over something that's insane. Over. Now, here comes the repetitions. See, I said A, B, C are number of repetitions. Let's look at M. There's a 1M, 1M. So that's 2 factorial. I look for anything else that repeats. Let's look. E. Look at this. There's another 2 factorial. We go 2 factorial also. And then see anything else that repeats. Nope, that's about it. Solve this now. 4 factorial is different. If you put over 4, that would be correct. Because 2 factorial times 2 factorial is 4. Because
4 factorial is 4, 3, 2, 1.
height.
But 2 factorial is 2.
Height.
And 2
Height.
is 4.
Height. Why is it 11 P5? Because there's 11 letters altogether. Would you agree?
Yeah.
Out of 11, how am I going to choose? 5. Because it's not 11 factorial more. Remember, we treat the question like I normally would, but when you have repetition, you got to divide this. Guys, you can figure out what it is. Very simple. Okay. Again, so if you have a calculator, I'm going to use a shortcut. 11 math, PRB, divided by 4. 13,860.
I didn't get that.
Whoa, 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 whoa.
Did you do the first part first? Or can you do it all together?
You can do it all together.
Do it.
You should get 13,860.
Oh, really? Look. I did it right.
What does the mode have to be in?
You gotta press enter first, then you're gonna do divide by 4.
What's that?
Mode could be in anything you want. So it'll be 13,860. One last question. And I'm going to give you some work. I want you to write a star beside this. Star. Supernova's going to be after lunch. I just realized something. Sometimes repetitions are hidden. You have to see this. On exam, a lot of people lose marks because they can't see the hidden stuff behind repetitions are hidden. See, it's easy when I give you a word. You say, oh, my son, there's 2 R's, 2 K's, and all this stuff. But if I give you a question like this, you have 8 cookies altogether. There are 3 chocolate cookies. 2 curry cookies. Yum. Whoa. You never tried it before. Add a bit of curry sauce to that dough and then, oh, yummy. Hard attack. No, I'm serious. It's the greatest.
He's joking.
Probably make.
I'm gonna have a.
Contest didn't make it.
I might need to talk.
Talk about it, alright?
It's a sad story. Sad story. 3
I know, right? That's shocking.
oatmeal cookies. I'm gonna make these curry cookies and push it to Strawberry Hill and just stand there, corner, send it to and Scott. Get your curry cookies. I did in Vancouver one. It's pretty nice. Free food.
The story was way better.
Yeah. Guys, gals, the question is, how many different ways can you eat the cookies?
What did you do when you went to Basaki? Just eat?
Eat, take pictures, and eat.
Did you just bring one bag with you?
Please, come on.
That was like-
I bring my whole family with me. How many different ways? Different ways. Can you eat the cookies? You're gonna eat all of them. How many different ways can you eat them? Good luck. Many ways of doing this. Again, there are 2 main methods. Permutation and blank method. Really, they go hand in hand. Sometimes easier to use blank, sometimes easier to use permutations. Again, nothing too bad. I'm going to pause it. Let you just have... You could, if you use the blank method. Nope. See, if you use the blank method, you would get 8 factorial, agree? But that's not your answer. This is where students make mistakes all the time. Because the chocolate cookies are really the same. Curry cookies are the same. Oatmeals are the same. So is repetition. This is why I said sometimes repetitions are hidden.
So can you do 8p8 divided?
Yep. So you have 3 factorial, 2 factorial, and 3 factorial. Or, if you use a p method, 8p8 over 3 factorial, 2 factorial, 3 factorial. This is one of those hidden things a lot of people lose marks on an exam. Because really, a chocolate cookie is really the same. Doesn't matter about how you eat a chocolate, they're all the same type of cookie. It asks you how many different ways can you eat the cookies. Guys and gals, this is called repetition. Don't forget this sort of thing when you write your exam, because repetition is crucial. You people lose a lot of marks because of this. Page, your work is done. Page 103. You should be able to do 1 to 10 now, and 22 to 27. We did most of it yesterday already, so, and you should be able to do every question. Hi, Amrahul, question. That's it, guys and gals. I'm going to give you some time to work on it, 20 minutes right now, maybe about 10-15 minutes after lunch, maybe, and then I'll start the combinatorics after lunch.